Over a period of 30 years, the Soviet Union became obsessed with Venus. Between 1961 and 1984, they sent a staggering number of missions to this hostile planet, missions that, for the most part, failed in catastrophic fashion. However, with every failure came more determination and ambition. Venus, the brightest object in our night sky, is shrouded in thick clouds and is a hellish world with temperatures high enough to melt lead. Its atmosphere is a swirling storm of sulfuric acid with crushing pressure capable of destroying most life as we know it. Yet, the Soviets seemed determined to get a closer look. While the United States focused on the Moon and Mars, the Soviet Union set its sights on something far more unimaginable. To those who learned about the highly secretive space program, it was deemed mission impossible. So why would anyone choose Venus, a fiery, inhospitable world, to explore? What drove the Soviets to spend so much time, energy, and resources on such a daunting goal? The Soviet Union's obsession with Venus officially began in the early 1960s with the launch of the Venera program, a series of space probes designed to explore the planet. The first of these, Venera 1, was launched on February 12, 1961, just 4 years after the Soviets shocked the world with Sputnik, the first artificial satellite. The space race was in full swing, and Venus, Earth's closest planetary neighbor, seemed a natural target for Soviet exploration. However, the first attempt did not go well. Venera 1 lost contact with Earth 7 days after launch, drifting helplessly through the void of space, its signal gone forever due to system failures. This underscored how challenging interplanetary travel truly was. Undeterred, the Soviets quickly followed up with Venera 2 on November 12, 1965. This probe also failed to return data. Just 4 days later, Venera 3 was launched with the goal of reaching Venus's surface. It managed to crash land, becoming the first human-made object to impact another planet, though contact was lost before any useful data could be transmitted. Despite these setbacks, the Soviets pressed on, refining their designs and deepening their understanding of Venus. By the late 1960s, they knew they were on the verge of something monumental. In 1967, the Soviet Union launched Venera 4, marking a breakthrough. This probe entered Venus's atmosphere on October 18, 1967, transmitting data back to Earth for the first time. Humanity now had direct information about another planet's atmosphere, revealing an environment far more hostile than imagined. Venus's atmosphere was 90 times denser than Earth's, with surface temperatures exceeding 900 degrees Fahrenheit. The air was composed primarily of carbon dioxide, with traces of nitrogen and toxic sulfuric acid clouds. Although Venera 4 was eventually crushed by Venus's immense pressure, its 93 minutes of data transmission marked a major success. Building on this momentum, the Soviets aimed even higher in the 1970s. In 1970, they launched Venera 7, the first spacecraft specifically designed to land on Venus and transmit data from the surface. On December 15, 1970, Venera 7 became the first human-made object to successfully land on another planet and relay information back to Earth. Though the landing was harder than expected, the probe transmitted valuable data confirming the searing temperatures and crushing atmospheric pressure on Venus. Each subsequent mission improved upon the last. By 1972, Venera 8 transmitted data for over 50 minutes, offering new insights into Venus's atmosphere and surface conditions. Photographing Venus was another milestone. In 1975, the twin spacecraft Venera 9 and 10 succeeded in capturing the first images from the surface of another planet. These haunting photos revealed a barren, lifeless wasteland of jagged rocks under an eerie, thick atmosphere. Venera 9 transmitted data for 53 minutes, while Venera 10 lasted 65 minutes, sending back detailed atmospheric and surface measurements. The Soviets continued to push the limits of exploration, culminating in the most advanced Venus landers, Venera 13 and 14, launched in 1982. Venera 13 survived an astonishing 127 minutes, capturing sound, panoramic images, and data about the chemical composition of Venus's surface, while Venera 14 sent back similar data during its hour-long operation. The Soviet obsession with Venus culminated in the launch of Vega 1 and Vega 2 in 1984. These missions deployed both landers and balloons into Venus's atmosphere, an innovative approach to studying the planet. The balloons floated for days, providing valuable data about wind patterns and chemical composition. However, with the collapse of the Soviet Union, their Venus exploration program came to an end in 1989. Despite decades of effort and groundbreaking discoveries, Venus remained largely unexplored. The Soviet Union's intense focus on Venus, driven by ambition and the desire to conquer one of the most hostile environments in the solar system, revealed a world more alien and deadly than anyone had imagined. Their missions gave humanity its first real glimpse into the planet's mysteries and left a legacy of innovation and determination in space exploration. Here's the text rewritten as a single continuous paragraph, preserving all the original content. The chemical signatures of once-present oceans, the rate of current volcanic activity, and the nature behind the highland regions suggest much about Venus's history. Researchers estimate that a probe sent there would last about an hour before crashing to the surface. Another mission set for 2031 aims to uncover where Venus and Earth's paths diverged. The Veritas spacecraft will study geologically active regions, analyze rock composition, and map the planet's surface in high resolution. Meanwhile, the European Space Agency is working on its next Venus orbiter, the Envision mission, scheduled for the early 2030s. This mission will focus on volcanic gases in Venus's atmosphere, surface composition, and inner structure. The coming decade may reveal more about this mysterious world. Until then, we could witness history, the first private mission to Venus. Inspired by potential biosignatures found in Venus's atmosphere, Rocket Lab plans to explore further, possibly launching as early as 2025. This mission could answer long-standing questions about Venus's evolution over billions of years. Such findings might even determine if Venus could support colonization. With its close location and Earth-like features, Venus may be a better candidate than Mars. The journey would take less time, and its gravity is nearly identical to Earth's. Terraforming Venus would require addressing its runaway greenhouse effect. Without it, the planet's surface temperature would drop to approximately -40 degrees Fahrenheit. For comparison, without greenhouse gases, Earth's average temperature would fall from 59 degrees Fahrenheit to -0.4 degrees Fahrenheit. One method could involve introducing water to Venus by directing icy comets at it, creating water vapor and clouds. These clouds would serve as a water source and help cool the planet. Alternatively, condensing carbon dioxide with other methods and introducing water could trigger reactions producing Earth-like minerals. Hydrogen, sourced from gas giants like Jupiter, could also be transported to Venus. It would react with carbon dioxide to form water and solid carbon, gradually reducing the carbon dioxide levels and forming oceans. Cooling could be aided by a space structure blocking sunlight, reducing surface temperatures to habitable levels. Living on Venus might be feasible in its upper atmosphere, where conditions are more Earth-like. At 30 miles above the surface, the air pressure and temperatures are similar to sea level on Earth, ranging between 32 degrees Fahrenheit and 122 degrees Fahrenheit. This area offers protection from cosmic radiation due to the thick atmosphere. Initial settlements could involve airships resistant to sulfuric acid, filled with breathable air, and expandable into floating cities that absorb sunlight and shade the surface. Once the planet cooled, settlers might move to the surface, though Venus's unique rotation, where a day lasts 243 Earth days and a year 225 Earth days, could pose challenges. Hypothetically, a mass driver could alter Venus's rotation speed. While colonizing Venus may seem ambitious, advancements in spacecraft design and floating technologies make it conceivable within the next decade. Elon Musk has argued that humanity must colonize other planets to ensure survival. Mars is often seen as the starting point. Musk predicts the first human landing on Mars by 2029, with colonies following shortly after. However, Mars presents challenges like dust accumulation on solar panels and sharp rocks that could damage equipment, as seen with NASA's Curiosity rover. The planet's surface averages -60 degrees Celsius, and its thin atmosphere provides no radiation protection or breathable air. Still, modern technology could address these issues, including creating habitats, using exercise machines to counteract low gravity, and producing fuel from local resources. Musk's Starship spacecraft, the largest rocket ever built, could deliver 100 to 200 people and 100 tons of cargo to Mars in 7 months. By 2050, Musk envisions a Martian city of millions under protective domes, sustained by hydroponic farms and powered by solar energy. Other potential colonization sites include the Moon, Mercury, and Titan. Mercury's extreme temperatures and lack of atmosphere could be mitigated by building colonies in lava tubes. Titan, Saturn's largest moon, offers dense atmospheric protection and abundant hydrocarbon resources but faces challenges from its extreme cold. However, its weak gravity would allow humans to fly with wings. Scientists have also explored concepts for floating habitats on Venus, protected by solar energy. For those dreaming of more distant possibilities, Stanford University has proposed a space settlement in the form of a rotating torus capable of housing 10,000 people, complete with artificial gravity and radiation shielding. Exploring these options could secure humanity's future among the stars.